Hi there, good afternoon and welcome to this session on GraphQL. So my name is Rob Crowley and I am the technical product owner or technical lead for APIs and authentication at Bankwest. And I work as part of the delivery enablement team. And one thing I really like about this team is that we build software for other developers within the bank. So our entire role is how can we let other developers, other delivery teams build more compelling user experiences for their particular cases. And that's awesome. And that's really one of the lenses which we'll be looking at today. So building GraphQL APIs such that your front-end teams can deliver better, more exciting and richer user experiences. And we've got quite a lot we're going to cover today. So I don't want you to leave today with just, I've seen a little bit of GraphQL in action. I really want you to understand the category of problems that it will help you with. Because then you'll be able to decide whether this is a tool that will help me or for what particular problems that you might want to look at it moving forward. After we've set that context, we're going to take a look at GraphQL in action. And for this, you'll see a couple of features. I think everyone's kind of like going to click and say, yes, I get it, right? I think this makes sense. From there, we're going to look at how you can actually use GraphQL effectively as part of your delivery pipeline. So in other words, if you're actually building it as part of a team, what are some of the tips and techniques that you can get the most out of it? But most of all today, realistically, we have an hour together. I will not be able to make every single one of you in the room an expert in GraphQL in 1 hour. But if I can inspire you just enough to leave the conference and learn more about GraphQL, that would be absolutely a fantastic outcome for me. So a little bit of context. So the recent shift to microservices, rich web apps, that's really had quite a significant impact on our ability to build really rich and compelling API experiences. So rather than just show you a little to-do app or something that's quite noddy, let's actually look at what a real-world site could look like today. So I think this is going to be pretty familiar to everyone. This is Amazon. And there is obviously a huge amount of data represented on this site. So if we were to build this, how could we actually decompose this site into a number of modules? And we could slice this from a number of angles. So first of all, from a data perspective, if we were to divide that down into, for instance, in a microservices architecture, it could look a little bit like this. So for instance, we could have some core product details from a product service. We could have some price from a pricing engine, inventory, promotions. Images could be served from a highly distributed image service, and so on and so forth. We could have certain details then for cross-selling. Each of these could have their own data store, could actually then be managed with its own pipeline, its own speed of change. But what about from a UI perspective? It looks quite different. Again, we could have product header information, product details, but then inventory, that's got data from a number of different services in it. The key takeaway here is that there's not a neat one-to-one mapping between a UI component and the underlying data services. So the question is, how could we efficiently deliver this data to the client? And what we're going to take for the next 5 to 10 minutes is a whistle-stop tour about how we, as an industry, has looked to kind of solve this problem over time. So starting off, we could say each one of the components could do its own orchestration. So it could call down to the various services that it needs, pull down that data, aggregate it, and put it on the screen. On the face of it, that looks pretty sensible. But when you actually consider over the network what that means, you're going to have an incredibly chatty series of calls from each one of these components, potentially over a very slow network link. Particularly if you're looking at emerging markets. That could lead to a terribly poor customer experience. So what can we do to improve that? So at this particular point in time, you might say, cool, what we could do is we could put it on an API gateway. And this then could then perform a general backend, and we can do certain aggregation here and deliver more normalized data to the client. And that could absolutely be effective too. But if you look at this as part of a delivery spectrum, this then can quite often become the constraint on delivery. It's generally managed by a particular backend team. If your front-end teams want to iterate quickly, the two have to be tied in sync. But that's really not the biggest issue with this. We don't just build websites anymore. Mobile is everywhere. Your company might have an upcoming line of wearable products. Each one of these experiences needs a different set of data. If you've just got one backend that's just serving this flat resource structure, you're either going to send too much data to the client or too little data to the client. There is always a trade-off. So what can we do to improve that? And at this point, we then looked at backends for frontends. So here we have each channel experience will have its own backend API. And that's quite cool, because this API is generally deemed to be an extension of the front-end product. So you're not really dealing with normalized resources. You actually say, how can I populate the data exactly for that particular view model? And again, that's pretty good. We've improved things. We've removed a fair amount of the constraints that we had with a single general purpose backend. But there's always complications. What about versioning? So again, with websites, we've been spoiled. To update to a new version, they just re-download the page. That's easy. What about mobile? What about wearables, where you actually have to version the API? What about different requirements over time? So I might have version 1 of my app. Just needs a small amount of data. We add features as we go, and over time, we're sending far more data down to the client. But if someone's still running version 1, why are we sending all that extra data to them that they don't need? Again, it's waste, particularly if you're in an emerging market where data is expensive. You don't want to be doing that. Again, we're having to trade off. So what do we really want to do in this scenario? If you had a perfect case, we would send exactly the data that the client needs, irrespective of the version and irrespective of the channel. And this is one of the cases that we're going to explore for GraphQL today. GraphQL lets us send exactly the data and only the data that each channel experience needs in one round trip to the server. That's amazing, because if you think in terms of a RESTful API, you might go, I will call the root level resource. It will return a set of children, and then I will actually go through each one of those child resources, pull down the information. It can have a lot of chattiness. We will see, irrespective of the data structure, one query to the back end. And just to highlight this as well, is we're not really tied to just fronting HTTP services. GraphQL does not care about the back end. It could be directly reading from a relational database. It could be SOAP over a web service. It's to provide that edge layer and a consistent interface outwards. So when you leave today, and if you're sufficiently interested in GraphQL, I've written a quick demo app based on Facebook's reference implementation of GraphQL server, which is written in JavaScript. And the goal of this is to answer the vast majority of the questions that you will have or you will face when you're starting GraphQL. How do you get a server up? How are the bits tied together? So you can explore that, and it actually covers like a number of reads, writes, and then some of the more advanced features, which we'll see as we continue through this presentation. So the example domain that we cover in that app is actually quite simple, but it's complex enough to actually show a number of interesting business rules. So far, it's one that we're probably quite familiar with. We have artists, and artists can release albums. Albums, in turn, are released on labels. And then we also have this concept of a user. So in this particular system, you will be able to have a user, and they will make reviews or create reviews on albums. And as we go through the type system later, you'll see that each one of these rules that we can introduce, and then it kind of changes the way that these interact. So let's take a quick look at GraphQL in action. And I think at this point, you'll kind of see the idea of, OK, I see how this thing works in sending the data back and forth from the server. So what I've just loaded up here is called Graphical. So Graphical is you can think of as the IDE for GraphQL. So if you download one of the GraphQL server implementations, you will generally get this as part of it. And this lets us compose queries in a pretty elegant way, and also then explore some of the API as we go. So let's just start off there and just start like our first initial query. So we'll just go grab an artist and get their name. Not very interesting as yet, because we could do that with REST right now. It would just look like /artist/ID. So let's do something a little bit more interesting. So, okay, so we looked at before, we said that, artists can release albums. That's cool. So now we go, okay, in one call, we say, artists now get all the albums that they have. Again, reasonably interesting. Let's continue. We did say then that, albums are released on labels. So now we can pull down all the information for the label. This is where things get a little bit interesting, because then again, what I could say at this point is, actually, grab me all the other albums that were released on that label as well. And actually you can see that these things, you can just grow them as you go forward. And you saw that each time I went to one of these lists, I'm actually getting a drop-down list of fields. It's somehow that GraphQL seems to know what a valid field or property is for this particular query. If I type in something that's not allowed, for instance, like foo, I get an error. It says foo isn't a valid member on this type. So that's pretty cool. So this, when I'm actually coding up my queries, I will actually know, well, what's valid and what's not valid. And that's pretty powerful. There's also then on the right-hand side, we can see certain documentation for the API. So we can see, I can do this set of queries on the root element. So I can grab labels, artists, albums, user IDs. And also tells me then what the valid inputs and outputs for them as well. So there's probably some people in the room now that's thinking, okay, so, there's probably some sort of schema or type system involved, and you'd be absolutely right. And actually, we'll look at how that's composed next. There's probably some other people in the room, though, and, it's, what are you trying to pull here? We could actually do this with REST before. And you probably could. Like, we could build an API, and we could then have, number of query parameters where we might say, okay, well, just return these particular fields. Then we could also do dynamic includes. And in fact, if you look at JSON API, it actually covers a lot of this functionality already. But the key point with GraphQL is it makes it absolutely trivial to do it. That's what it's designed about. Absolutely, if you had a team and just to support one particular channel system, cool, you could probably make that work. This makes the functionality available for a vast number of use cases. It is incredibly quick to put a GraphQL front end on top of your legacy APIs or legacy backend suite, and then be able to move quickly forward. It's not talking about weeks and months of development to craft a REST API. And even as my role as technical product owner for APIs at the bank, even trying to get consistency in a REST APIs that build from one delivery team to another, it's actually a bit of a nightmare. There's a huge governance process the second you look to scale. GraphQL enforces a consistent interface. So at this point, we've got to sidestep a little bit. And I want you to really understand what was happening behind the scenes in that quick demo. So GraphQL itself is comprised of three main parts. So we've already seen the query language on the right-hand side. So this is when I was typing into GraphQL. You can see that it defines rules such that each query has to open with a curly bracket and close with a curly bracket. It defines what the valid syntactic structure of a query is. The type system on the left is a user-defined schema or set of types. So in our particular domain, it is albums, reviews, artists. On the right, this is part of the standard. On the left in the type system, this will be bespoke to your particular domain. When you combine those two together, then that's what allows us to process that query. And that's done by the execution engine. So generally, this will be the GraphQL server. And it has two main jobs. First of all, validation. So as I said before, you always know whether it's a valid query or not based on the language and the domain. You can mathematically prove whether that query will be successfully executed. If validation passes, then we will be into the execution phase. And this is one thing that I incredibly like about GraphQL, particularly when you're trying to scale it in an organization. And this is a quote from Bertrand Meyer. You might know him from Design by Contract. And this is even in an OO language. We can generally have inconsistencies at module boundaries, so interfaces. And that's between two parties. Imagine how much worse that is with REST when we don't have a strong interface is just implicit typing. What's a valid query up front? What's not? You can eliminate a whole category of issues right up front. And again, there are ways that you can mitigate this with REST. So at Bankwest, we use consumer-driven contracts a lot, whereby each consumer of an API can then express their own set of requirements for that provider scope and say, of these 10 fields, I'm only interested in these few. That works really well when your APIs are used internally, when you have a known number of consumers. That does not work well at all with public APIs. It just does not work at all, and that's where the technique falls down. So what does a type look like in GraphQL? And we could define them quite succinctly. So in this case, I say it's an artist, and the artist has an ID property. So in this case, ID is just an opaque identifier. It's got a string, that's a name, and the exclamation mark on the right-hand side basically means non-nullable. A value is required. It's got a number of aliases. Denoted, this is a list by the square brackets at the front and at the back. And GraphQL supports a number of other scalar types. So it supports booleans, floats, but you can also define your own custom scalar types. So for instance, if you had a particular type in your system, so for instance, you might want to create one for a date time. If you say, I want to have ISO 8601 format for my dates, you could absolutely create a date scalar type. Or for instance, you might have one to say, is this a valid URL? So again, the demo app shows you how you can actually create those scalar types and actually extend that type system yourself. Probably most interesting, though, we can actually define a relation to another type that we defined. In this particular case, album. So we can say this artist will have a collection of albums associated with it. And this relation is actually what lets us traverse down when we were executing the queries. So now that we have a hierarchy of types, how did we actually get that query executed on the server? So each type and each field on that type has a function associated with it. So for instance, at the root level, we associate this particular function. And in this case, this can be whatever you want it to be. Purely, you will take, in this case, one input parameter, which I had as the artist ID, and I just execute some arbitrary code to return that model. And then each field of that, you can assign another function to it. So in this case, the artist name will just be retrieved by passing in the artist, which was returned by the root resolver at the type level, and then just pick out the name property of it. But that, again, you can write it to be as complex or as simple as you need it to be. So let's look through a query and actually then see how that would actually be conceptually executed on the server. So again, this query is pretty straightforward. It'll say, for artists with ID of 5, I want to get their name, I want to get the list of albums, and then off the albums, I want to pull out the title and the name of the label. So the first thing that would happen is after the query has been validated, it would hit the resolver at the type level for artist. And it would then, in turn, retrieve the artist model at that point in time, and then pass that data to the name resolver and the albums resolver. First off, it would just retrieve the primitive name, and in this case, it might do another backend service call to retrieve the collection of albums. At that point in time, the result of each one of those albums is going to be passed to the album resolver function. And again, it's going to go through the exact same process. It's going to call the title field resolver and then go to the label, and in turn traverse down to the label resolver itself. So what you can really see is that the structure of the query that we pass in is literally then just parsed, and each one of those nodes executes a piece of code in the back end, and we just keep iterating down until we reach the leaf node of the query. That data then gets bundled up and returned. And that's why on the server side, and actually, we could have multi-arcs here as well. This doesn't actually have to be a straight, I could absolutely go from label back up to artist across to user. This is all defined by yourself. But the query itself will just be parsed, and then for each node, and for each edge, which is the relationship between two nodes, you will just execute that particular function on the back end. And that's where you can actually grow arbitrarily deep queries on the left-hand side, like in the query, to be executed on the server. And this is really a fundamental difference to what we have with REST. With REST, we model resources and state transitions between those resources. So we define on the server side how the client is going to interact or retrieve that data. With GraphQL, we don't do that. With GraphQL, we focus on creating the hierarchy or graph of objects on the server side. And then the clients can express their interest in a subsection of that graph. So we don't actually mandate, here is exactly the call that you can make. We express the capabilities, and then each query is the requirements that they need on that particular graph. So there's a number of types of operations that you can do with GraphQL. So far, we've been looking at queries, things without side effects. You can also do mutations. And mutations there are when you will actually send a command to the server, side effect will happen, and you will return the data back again. Just like REST, these are conceptual or semantic meanings. There is nothing to prevent me from sending a query that did do a side effect or a mutation that didn't. Just like REST, I could do a side effect with a GET. It's not best practice, but you absolutely could if you wanted to. And in each one of these types, it's one request and one response. GraphQL also supports subscriptions. And this is something we'll look at later in the talk. But here it's radically different. When I do a subscription, I'm saying I express an interest in 0 or more occurrences of something at some time in the future. So I'm not actually expecting the data to come back to me straight away, but I may get some data at some point in the future. So as you can see, these are stateless operations, but we will have to introduce some level of state or persistent connection on the server to support that. And we'll see how that works later. So the second killer feature of GraphQL over and above the type system is introspection. And what this lets us do is actually issue queries against the schema itself. So I could ask the GraphQL schema, how many types do you have in you? What are the names of those types? And in fact, if you looked at graphical, that is exactly what it was doing to provide that drop-down list of available fields. It was issuing a query to the server for this particular type. What are the valid fields for it? And that's also how it generates the documentation tab that was on the right as well. So obviously, type ahead is one possible use for that. What about code generation? So if I already know what my query is and the structure that I will get back, why could I not generate a view model directly for that? Why couldn't I just do all the translators for that? You absolutely can. This gives you a huge amount of power to do things, not at runtime, but at build time. And again, you can also use that as a valuable source of documentation, maybe just like you do with Swagger today. So over and above the efficiency of a single call to the server and back, this is actually quite beneficial for a client as well, because no longer do you have to issue multiple calls to backend services and then aggregate that data on the client, or if one of those calls fail, have to handle the retry logic. All of that burden is pushed to the server. We will either get the result back or you won't. If that fails, just make one call again. So all of that is then handled on the server. So great for client developers, actually pretty good for us API or backend developers as well. Because we, again, don't have to worry about exactly how we model the resource, though. We express the capabilities of the graph, and then each of the clients then can query against that. Just to be clear, like the examples that I've showed you today are all in JavaScript. GraphQL does not equal JavaScript. There are implementations in the vast majority of the popular programming languages today. And in fact, some of these implementations are actually more feature-rich than the reference implementation from Facebook. So for instance, in the Scala space, they have Sangria, which was actually one of the first backends to support that push-based subscription model as well. So I strongly encourage you to check that out. There's ones in .NET, there's ones in Java. Huge selection as well. So don't think that if I'm going to use GraphQL, I have to move my whole team over to JavaScript on Node. That's not the case. GraphQL is not tied to HTTP. They're quite strong on that in the spec. The vast majority of the implementations will transport it over HTTP. but we may see a shift in that moving forward. So long as the protocol supports exchanging character data, that will be sufficient for GraphQL. GraphQL is not a great fit for binary data. So for instance, if you want to handle file uploads or file downloads, GraphQL is not for you. So that's why I don't see it as a complete replacement for REST APIs that you might build. It is absolutely fantastic when you have data to expose to a number of different clients, and those clients have different data requirements. So don't leave today thinking, I will take all of my REST APIs and just map them across. They will absolutely continue to cohabitate in your ecosystem. Versioning. You can't talk about APIs without versioning. And in fact, when we actually talk about versioning, and Roy Fielding was asked, the father of REST, when should you version a RESTful API? And his point was just like, just don't do it. And there's always a trade-off when you do that. I'm a bit more pragmatic. I think at certain points in time, you do have to take that step. And there's a myriad of ways we can do that with a RESTful API. We can stick a version number in the URL. We can stick it in the header. We could do it properly and do it as a media type. But again, there's always that concern that when you do it, will you be leaving old clients behind? And Roy Fielding's sort of viewpoint on this is you should always look to have a graceful evolution of your API contract. So again, just add fields over time, then check the usage, and if they're no longer being used, then remove them. And in fact, GraphQL supports versioning by not supporting versioning. So again, it forces you to do the exact same thing to gracefully evolve your API. And it provides some tooling for that. So you can mark a field as being deprecated. So what this will do is when you're doing an introspection query to generate the documentation for your site, new consumers will no longer see that field. Because you know exactly the fields that the client is interested in, it's actually really easy to gauge, is it safe to remove this field? Whereas if they're just pulling down one RESTful resource, you don't really know, are they using all the fields of that resource or only a subset of them? So this actually makes evolving your API, I wouldn't say straightforward, it never is, but at least it makes it deterministic in terms of whether a field is being used or not. And if you know it's being used, then you go and have those conversations to say, this particular feature will be sunsetted at X point in time, come on board. A key point is GraphQL will not make you a database or like an API expert. Modeling skills across, any sort of like data environment is still table stakes. So if you are having issues, building or like having governance across the APIs that you build in your organization today, GraphQL will not instantly make that better. It will provide you a layer over the top where you can probably cover a multitude of sins you've made before and make, build it the way you wished you had the first time. But if you just rush into it, you will be using the deprecated feature an awful lot. So absolutely plan it. If you don't, you may come unstuck. But it would be remiss of me if I didn't offer you some sage advice about how do you, model your GraphQL schema effectively. And a very useful bit of information that you actually see in like a lot of GraphQL talks is thinking graphs. That's very zen, isn't it? But what does this actually mean? Don't create fields that should be types. So effectively from there, if you create, let's just say I wanted to, extend, the artist type, and I want to say, what producers have they been linked with? Don't just create a list like producer ID with a scalar value. Rather create producer as an object and then assign a name or an ID to it. Because what that lets you do is gracefully extend the producer type as more data becomes available. So what you should always be thinking of is, how can I create separate nodes for each one of those types, and then the relationship between the two of them? So again, we're going to look now at using GraphQL as part of your delivery pipeline. And what are some of the things that it does really well for you? What are some of the things that you should be concerned or pay special attention to? And the schema is absolutely fabulous for making deterministic queries. And on the other side of that, it actually helps with API documentation as well. But it's really developer-focused API documentation. It gives you information on what the types are, a quick description of that field. But if you were creating a public API, you need out-of-band information as well. So for instance, how do you sign up to get your API key? Is there rate limiting? What about security? None of that will be part of the schema. So if you really wanted to use this for public API documentation, we need to do something a little bit more. And there's a number of tools in this space. So this is just one called GraphDoc. And what this lets you do is take the GraphQL schema that you have and combine it with Markdown documents to create offline accessible documentation. So this is incredibly powerful because you can still get all of the benefits of the GraphQL schema, but then write your own custom documentation with it, and then combine the two. And then actually have that in either a PDF, something that you can just hand to someone, or as a separate website as well. So strongly consider something like this for the environment in which you're operating. Don't roll your own GraphQL client. So there's a number of clients in each one of the languages that we use, and they will actually help you build the query on the client side, and also really help you, managing the various sort of like aggregation of subqueries that you might have in the UI as well. So if you're using GraphQL, you should absolutely be using a GraphQL client. And one of the key things that they do for you is really help you with caching, and we'll see exactly how they do that in a few slides. In the JavaScript space, you've got three main options, or at least two main options, and then sort of some other ancillary ones. So first of all, you could use Relay, which is Facebook's implementation as well. Then you can have the Apollo GraphQL client, and Apollo are huge in this space as well. And actually, the Apollo client is the one that I use for the vast majority of work that I do. It's very simple to get started, and it just allows you to deliver value really quickly. Then there's also some lighter weight ones like Cache. Again, if you look at the reference slide at the end, you'll see where you can go to see where all the available clients are for your particular language. If you are going to support Relay, and Relay is the client library that Facebook uses for data-driven applications, decide this really early on. Relay is incredibly opinionated about how you need to structure your graph. So for instance, Relay mandates that between each node, so that edge, you actually have to model it as a connection itself. And that connection then defines that relationship in more detail. So you could include things on it like, paging information, how you should be paged, total number of records. So you really there is actually, the GraphQL spec is about that big, the Relay spec is about that big, right? So if you're going to do that, particularly again, if it's going to be a public GraphQL API, I would encourage you then to look at Relay, because then that's going to be more flexible for your consumers. But if it's for internal use, maybe you need it, maybe you don't. If you think you will, learn Relay up front, learn what it gives you, and then make that decision. It's going to be nasty to add it on afterwards, though. With RESTful APIs, and this is a large part of my role, I really care about three things. I care about what protocol the teams are going to use. I care about what media type the teams are going to use. And again, the media type will define how the different APIs can actually communicate the structure and become interoperable. And the last one is naming. And GraphQL is no different. Naming will be absolutely key for this. So there's a number of simple rules that you can come up with. So for instance, any Boolean field can have a name that resolves to a predicate. So is, can, has. For collections, maybe you make them plural nouns like what you would with resources. I'm not writing these up to be prescriptive. Absolutely make these make sense in your own domain, but come up with guidelines around naming up front, because GraphQL really gives you a second chance to get this right. Don't squander it. Otherwise, you will be using deprecated a lot when you suddenly figure out that you want to call it something else. And a bit of advice from sort of like my sort of years of building APIs is really look for terms that reflect the terms of your business. So talk to your product owners, talk to your users, and see if there's certain names that come up time and time again. So maybe not going quite to the sort of depth of like ubiquitous language with domain-driven design, but look for names that resonate with the business. There's also a number of really good resources online for this as well. So schema.org, you can go to and then say, okay, well, what are the properties that you might find on a person? So for instance, you might have, do you call it a nickname? Do you also call it like also known as? What do you name those fields? If you go to schema.org, it gives you an industry standard which would actually say alternate name. Like, it just gives you a tool to maybe get away from some of the bite-shedding conversations that you might have within your team. So naming, right? It's tough. You will spend a lot of time on it if you're doing it right. And caching is always the other one. And GraphQL really mandates a different approach to how we handle persisting state on the client. And with RESTful APIs, HTTP is absolutely amazing. It gives us such fine-grained control with cache control, e-tags for conditional gets and conditional requests, vary if we're going to do it based on personalized details or not. And what we could also do is introduce intermediary caching layers. So RESTful APIs by design are very chatty, but we mitigate that chattiness through intelligent caching. So again, if we, for instance, with cache control, we could put a shared max age and put that geographically close to the clients as well. Very powerful. GraphQL doesn't play nice with the web. And that's, if you're Facebook, that's fine. You can, build, custom, caching layers if you've got like endless resources. With Bankwest, we don't. We really wish that they actually used HTTP, more effectively. And I really hope that this is something that will change in the GraphQL community moving forward. But right now, it treats it as a dumb pipe. So if you're looking at caching, you are looking at what can happen on the server side, and in turn, what can happen on the client side. Any sort of intermediary caching layers, so Varnish or Squid or any solutions that you might be using today, they're not going to be super helpful moving forward. So what should you do on the server side then? So like I mentioned before, GraphQL is often a thin layer on top of existing services that you already have. I would absolutely recommend that you then look at a caching layer in GraphQL as well. So this could be Redis, this could be anything from there. And the patterns are really quite simple. So for instance, for a get, first of all, try to get it from the cache. If it's not there, get it from the underlying data store, add it to the cache, and return the object. For the case of a mutation, in this case, I'm adding an album, add the album to the database, then basically retrieve the album you just added. And you don't want to use the input model because you might actually have additional properties that were created, like create date or any other sort of metadata. So retrieve it from the underlying store and then save it. It's as simple a pattern as that. GraphQL also often comes with data loader implementations. So if you look at any of the sort of like starter documentation for GraphQL, you will hear data loaders a lot. And what that really does is provide you per request caching and batching to the down-end processes. So for instance, batching would be if I was retrieving each one of those albums. So for instance, if our artist had 3 albums, instead of making 3 separate calls to the back-end system, it could actually batch them up and send one request to your underlying services for those 3 albums. So again, the vast majority of documentation, which you will see with this, covers data loader in quite some detail. Also, in the demo app that I provide you, I actually show you how to actually use data loader in a couple of different cases. The biggest change for caching happens on the client side. And this is really one of the key points for why you want to use a GraphQL client. And instead of storing the hierarchical tree of data that comes back from the server, the GraphQL clients themselves actually break each row of that down and create a normalized cache for it. So this is actually a pretty amazing thing, and it's probably too much detail to put on the slide, but again, it's quite covered in the relay spec as well. But what this lets the client do is make very intelligent caching about this is a piece of data within a tree structure that I already have. And if you're issuing a second query, you can then say, I already have this. I don't need to go back to the server for it. So even though you're expressing your data as that query, that mightn't be exactly what's sent to the server because you could have client-side caching there as well. So inter-API communication is really the lifeblood of REST. It's actually how the web works. And hypermedia is actually probably one of the most misunderstood sort of concepts when we're building REST APIs. And if you look at what Roy Fielding described it as, he said it was the simultaneous presentation of information and controls such that the information becomes the affordance through which the user receives options and takes actions. Everyone get that? It sounds like a bit of a funny topic, but it's actually something that a lot of us will be familiar with. So for instance, HTML has a number of hypermedia controls in it. So for instance, it has the anchor tag. So what that says is when, and basically whenever the client parses that, it will know if someone clicks on that anchor tag, it will dereference the resource identified by the href tag. Cool. It's got an image. And basically, it will say whatever resource is defined by the source tag, it will then pull down that image and show it in space in the screen. And it's got forms. And forms will say, I will take whatever data has been entered by the user, send it to the server, and refresh the page. And hypermedia, with regards to this particular REST request, in this case, the client is calling the artist API, is the underscore links element, which is defined by the HAL media type. And what this lets you do is any client that then understands HAL will then know, OK, I can parse links, and I know that I can actually then dereference that particular event's URL, and this will be the format of the data that comes back. So again, it's about delivering data that's in band with the request, and then the semantics of that data is understood by both parties, other than having to go to the documentation, figure out what it is, and then come back. And this allows us to switch between APIs really easily. So I can just link between various APIs and pull down the data. And you'll see that that will be like an incredibly common pattern. It's not that easy with GraphQL. You can't easily federate between schemas with GraphQL. So GraphQL really wants you to have one big schema up front that covers everything. And that's actually, might sound like quite an impost up front, but what you should really look to say, if you need to access that data, ideally include it in your graph. If you can't, then unfortunately, you will be back to falling down to documentation to try to figure it out. So for instance, if I call the GraphQL API here, I can get back this URL that just points to events API and the performers with ID of 8. What's the structure of that? Is that going to be XML that I get back? Is that going to be JSON? It could be anything. We just don't know. Whereas obviously, if we included that as part of our schema, then the client would be able to know exactly what was on offer in it. So the other thing I think we should talk about as well is authentication and authorization, and where does that fit in the work that you'll be doing. And in this particular diagram, we actually have both of those in play. So first of all, when each person gets to the gate, they will say, who are you? And I will present my passport. At that point in time, that's the authentication part. And at that point in time, they'll say, well, do you have a valid visa to enter the country? That's going to be the authorization part of it. And authentication should really be handled as a cross-cutting concern. So again, you will not move, or in all likelihood, you will not move from REST through to GraphQL and everything be covered by it. You will have a bunch of legacy code, maybe some stuff, sort of like RPC stuff, or some REST APIs. Handle it as a cross-cutting concern. So again, that might be OpenID Connect Node just as a secure token service, and that JWT can then be just propagated down to GraphQL. Authorization, on the other hand, is inherently a domain-specific concern. It is incredibly difficult to handle that, or I would say nigh on impossible to handle that as a cross-cutting concern. So where should the authorization logic go? You could obviously stick it into the GraphQL resolver layer, and that's probably quite an easy way to get started. But again, what happens then if you need that in the REST API or in your RPC calls as well? Keep GraphQL agnostic of authorization logic. GraphQL should be an incredibly thin layer over existing services. But what would that really look like then? So as a user, for instance this, I want to be the only one permitted to see my personal details so that my right to privacy is respected. Seems like a pretty legit user story. So from a model perspective, I always look to get one source of truth for how you would retrieve one of those models. So irrespective of what entry point on the graph, there should be one way of retrieving each type of entity. So in this particular case, I just issue, every call will say to get a particular user, we'll go through this method. It takes 2 arguments, it takes an ID and the viewer. And the viewer is the context of the person making the call. And then I basically just check to see whether the viewer login equals the requested or the returned object login. And if the two match, you return them. If not, just coalesce it to null. And don't throw an unauthorized request here. So again, if you're in the client and you've got a big tree of data, don't invalidate the entire tree for just one node. And that's generally the practices that are adopted with GraphQL. So this approach works really well for first-party systems. But what about third-party systems where you've got delegated access? So it's not only what the permissions the user has themselves, but what permissions or scopes that have been assigned to the platform that the user is making the call from. And in this particular case, it is absolutely OK to do coarse-grained authorization in your GraphQL layer. So the authorization shouldn't be the sort of business-type rules like I just showed you. But from here, what I've done is I've annotated the type definition. So this is just one looking in JavaScript with this allowed scopes property. So in this particular case, it could look at the JSON Web Token, which is effectively the access token for what the person has authenticated with, and basically check whether it has this particular scope. If it does, it will then allow that call to be propagated to the downstream south-side APIs. If not, it will terminate that right up front. Coarse-grained authorization, absolutely OK. Do not put fine-grained authorization in your GraphQL layer. You can actually annotate, a number of different custom properties in your type definitions. So for instance, GitHub use a technique whereby they add visibility or audiences to their types. So they can actually then do, this one's for internal use at GitHub, then this one's a public use as well. So always think that as an extension point, you can actually add your own data to type definitions. So far we've been pulling data. What if we could push data back to the client? And this is what we hinted about before with subscriptions. So again, a requirement here, as a user, I want to be able to be notified when my favorite artists release albums so that I can keep up to date with the music that I love. And in fact, many of the applications that we create today need this rich sort of like interactions of data. It's not, I'm going to pull down some data and then nothing happens. As the user experience that we're building now become richer and richer, you really need to think about how could it actually be informed when something happens on the back end. So we have a number of choices for real-time APIs. Like traditionally, we probably would have done polling. And polling's absolutely fine if you know the refresh rate of your data. So for instance, if we had product rates, interest rates that refresh once a day, sure, I'll just make one call a day. That's grand, because I know when they're going to be refreshed. If the data is more organic or evolving in nature, then polling quickly becomes problematic. Do you poll all the time? It's going to be chatty. Do you do it too infrequently? You're going to get lag in the user experience. What we really want is something to be pushed to the client. And there's 2 main options. First of all, there was this idea of live queries. So this is where you could say, I'm going to make a query. And if anything with the underlying resolver layer changes, I just want to get a fresh copy of that query pushed to the client. Really, really, really hard to implement. So what the industry or what the kind of community have got around is actually subscriptions, which is event-based. So what we actually do here is express an interest in something happening on the server, and then we will, when that happens, we will then get that pushed back to the client. And the subscriptions RFC has already been raised, and it's actually the most recent release of Facebook's Reference implementation supports subscriptions. And the general idea here is I want to be told when something happens on the server, and at some point in time when that does, push that data back to me. They're read-only. They're defined in the exact same way you would any other GraphQL query, and they're absolutely not a replacement for queries. You will not suddenly stop using queries and everything's going to be subscriptions. It's just going to be when something of interest happens on the server, you can then register your interest in this. So you'll be using the 2 in concert. So what does it actually look like? So on the left-hand side, we have what a typical request-response model would look like. So obviously we said that subscriptions are stateful. So you need sort of like two-way bidirectional communication. And this is where this transport layer on the right-hand side comes along. So each of your GraphQL types could then expose a subscription method, which will then be looked at by the subscription handler. And then the client will then have the active subscription defined for that. When something of interest happens on the server side, it can then raise an event. The event will be added to that same channel. And then everything going well, that subscription will be raised and pushed to the client. So let's walk through a real example for what that would look like. So in this particular case, the client opens up a call, in this case using WebSockets, to the subscriptions endpoint, which I've called /subscriptions. Doesn't have to be. There's not a standard there. And it basically then defines this particular structure, or this query. So it gets subscription, and I want to be when an album is added, and I want to get the album title and the artist name. So what's nice about here is it's not a fixed structure of the event that gets pushed to the client. The client still defines exactly the data structure that they want. At some point in time, the admin user then adds a particular album. We then see whether that particular user is interested in that event and whether that event is actually for one of the artists in which they're interested in. And then it pushes back the data to the client. And this is exactly the example that I do as part of the demo app as well. So you'll be able to look at the code that actually powers this. So in the last couple of minutes that we have, we'll look at a couple of other techniques that we have for low friction development, like how can you move quicker with GraphQL. So the first piece of advice I would give you is always start with the schema. So the schema is what will give you shared understanding between the client team building their app and the server team building the API. Once the schema is agreed on, both teams can work in parallel. So you're not waiting for the full API to be available. And at this point in time, once both of these are complete, you can then integrate them into the product at the end. And finally, rinse and repeat and ship. But always start with the schema first, and then we'll actually quickly let you iterate the design, rather than I've built it, oh no, wait, that's not quite right, let's start again. So if the client team, though, is going to be working in parallel, you're going to have to find a way to mock the data or use an API that's based on not the actual backend. And there's this really awesome tool, which I absolutely love, called GraphQL Faker. And what that lets you do is actually set up a dynamic faking or proxy that will then let you not only completely mock a backend, but also enrich certain functionality with it. So the first thing GraphQL Faker does is it takes in a schema. And at this point in time, the client can then issue a request to the GraphQL Faker proxy containing some of the real data and just some faked data that we've defined in GraphQL Faker. The real portion of that request will be sent to the backend server. The backend server will then actually send back what the real data is. We will enrich that with some faked data, and then that goes back to the client. So you can probably see here is if you're just quickly iterating on the design, you don't actually have to change the API. You could say, oh, well, what about this field? Does that look right? Or you want to change some of the details for that? And in fact, let's just take a real quick look at that as well. So what we can do here is using the extend notion, we can actually then add additional properties to types. So in this particular case, I've added a site property, which I've just set as non-null string with just of type URL. So if we actually go back here, what I can just do to sort of illustrate it, we can say just retrieve any old album. And I want to retrieve, the, producer details for that. And at this point in time, I'm just going to say, well, it's, I don't know what a producer is. It's not a real field. It doesn't exist in the back-end schema. So what we could then do is basically go in and say, OK, well, actually, let's just define what one of those would look like. And on here, I can just say, OK, well, I will create a field that's called producer, and I will make it of type producer. Now when we go back to the client, I just get that mocked data. And that can be as rich or as simple as you want it to be. But what that lets you do is really rapidly, without having to change and deploy your API, iterate on your design. Couple of points to finish with. Telemetry is absolutely key for GraphQL. You could obviously see that the client could send arbitrary depth queries to the backend. Absolutely put timing details at every point in your backend, because performance can be key. And you really want to see what query came in and what queries on the south side did you actually execute to the backend services as well. So think about this up front. If you don't, it could be painful to add in afterwards. Or worse, you're in production and something's running slowly. That's not the situation you want to be in. And again, build support for a phased release process. So figure out, if you're going to have one schema, how you can actually do pilot launches for that. So again, that might be through custom properties on your schema. So again, saying this is for internal use, this is for public use. That's the technique that GitHub use. But again, you want to find a way that you can actually put out these features and pilot them, see that they're actually solving the problem before you get into that costly deprecated versioning sort of approach for that. So as you can see, I really hope that you've taken that from an efficiency point of view. GraphQL can let you take exactly the data that you need and send it to each client experience. It can really help you with documentation. It can help you fix some mistakes that you might have made with your previous implementations. And it's really incredibly good at solving the problem of multiple clients that have very different data requirements. So thank you. I really hope that you've really enjoyed the GraphQL talk, and I really hope that all of your API consumers become little heroes on the back of it. Thank you. OK, so we have 3 minutes for questions if there's anything from the floor.
So what was the recommendation for pagination of large data lists?
So the question is, what is the recommendation for pagination for large data lists? So one of the things I didn't show you, which we can run through afterwards, is that each one of those connections can actually take a number of inputs. So for instance, here we have albums list. And I could actually pass in, some details here. So in this particular case, I say that I just want, the first 2. But that absolutely could, and likewise, I could do things like, order by. These are just things that I've defined myself. This absolutely, then you could pass in a number of arguments which would say first 50, second 50. So with a GraphQL API, I would generally actually recommend that you do cursor-based pagination. So you will actually just pass back a opaque cursor identifier, which will then actually abstract away the pagination mechanism, under the hood. Good question. I think we have time for one more. Sorry. Yeah, was there a question there? OK.
You mentioned about being able to change the data through the. That feels a bit dirty. I'm not sure if I'm just misunderstanding the use case there. Using it to change data, the modify approach. Query.
Well, so I guess the question is, are mutations, sort of like a dirty concept in GraphQL? I guess the primary use case for it was always about a query language is actually retrieving data. And if you look at mutations, they are effectively exactly like an RPC state where take this particular set of data and apply it on the server. You could argue it's a bit of a bolt-on, but I personally see nothing wrong with RPC. I like REST. I like GraphQL. I think they're all perfectly good techniques for the use case ahead. The alternative then would be that you try to model updates in a different way. One of the key things, though, that I really like about REST is when you have a workflow along the business process, and you can actually reify that as a resource. So for instance, you might create a pricing request, which might go through multiple phases. So it might start with an open state, and then go to approved, then go to closed. And at each one of those transitions, you can then apply certain business rules to say, well, what can you do next? That's something that you won't get from GraphQL. I think that's all we have time for. If anyone else wants to come up and have a chat afterwards, that would be good. Cheers. Thank you.